Hi, this is Chloe Cummins from the University of New England in Australia. I would like to start by thanking my co-authors and Rob Pacey for providing my colleagues and I with the opportunity to present the main findings from one of our recent publications within the International Journal of Sports Physiology and Performance. The main purpose of this study was to utilize Global Positioning System, or GPS and accelerometer data, to quantify the external training loads of a rugby league team across a pre-season. In doing this, we specifically categorized players into one of 4 positional groups to identify the training demands within 4 types of training drills, being speed and agility, conditioning, generic skills, and positional skills. These were the 4 main drill categories prescribed by coaches within this particular rugby league team, and the aim of the project was to quantify differences in the physical demands with specific reference to positional groups for each training drill prescription. Whilst the rugby league preseason in Australia begins in November, all training data from November and December was excluded, as many players undertook limited on-field training sessions due to international playing commitments and off-field surgery. Therefore, all data was collected over an 8-week period from January through to the start of the season in March. Now, if we move to the results, one of the main findings was that the duration of both speed and generic skills went down, leading to a decreased overall load across the preseason. Now, these decreases coincided with an increase in distance, high-speed running, very high-speed running, and 2-dimensional body load demands within positional drills. For those who aren't familiar with body load, it's really a measure of the volume and intensity of accelerations, decelerations, changes of direction, and impacts. Usually, all 3 accelerometer axes are examined within this variable. Yet pilot work from our group actually suggests that 2-dimensional body load, in which that vertical axis is removed, is more sensitive to changes in collision load within rugby league. And due to this, only the 2-dimensional load was used within this paper as an estimate of the contact load. Now, if we turn our focus to the positional drill specifically, hit-up forwards completed less very high-speed running than both the outside backs and the adjustables. Yet what we can see is that the hit-up forwards completed greater or undertook greater relative 2-dimensional body load demands than the outside backs. So I guess the real question now is, what do these findings actually mean to a rugby league practitioner who is planning a pre-season? To the authors, the main finding is that the specific quantification of positional and generic drills may enable practitioners to better individualize the training prescription and periodization of their athletes. Somewhat intuitively, physical demands differed when players trained in their respective positions. These differences may help forwards to develop collision and contact abilities, while simultaneously enabling backs a greater opportunity to train their high-intensity running capacity. And as these physical load profiles more closely mimic that of the match load demands of rugby league, these drills may be utilized in the latter stages of the preseason to simultaneously prepare athletes for the specific physical, technical, and cognitive loads of match play. Conversely, practitioners really should be aware that training within specific positions may limit the development of certain physical capacities. And whilst these demands align with normal in-game profiles, practitioners may consider alternative drills to train less frequent physical requirements. For example, forwards typically complete lower amounts of high-speed running in a game, but they may encounter less frequent situations where greater volumes are required. As training within that position does not seem to overload this capacity, alternative drills may be considered at certain phases of the preseason to develop well-rounded and resilient athletes. Whilst minimal differences in physical loads were evident between positional groups during generic skills, these drills, along with conditioning and speed drills, are likely essential in developing physical capacities and improving or maintaining proficiency in fundamental rugby league skills, and really serving as a platform for subsequent game-specific training and ultimately in competition performance. It was also clear that there were differences in the periodization strategies from the early to the late preseason. This particular case showed a logical progression of more generic skills in the early preseason, building towards a greater amount of game-like positional-based drills in the late preseason. And this progression is likely essential in helping to build a base in which specific rugby league performance can really be built upon. This work also really highlights the importance of incorporating both positional and non-positional specific training drills, as only undertaking work within positional groups with very specific physical requirements may actually underprepare individual players for less frequent or demanding abnormal passages of play. I'd like to thank you for taking the time to view this audio abstract, and please feel free to ask any questions or start a discussion on this paper either via email or Twitter.